Alright, hell yeah. We got statics. And we got problem number 4. First chapter. Hell yeah. First chapter stuff. You know what I mean? Using units. And we're going to convert SI units into US customary units. So this is mass moment of inertia. It says, hey, if I got a string and I got a distance on a radius and I'm spinning this thing around in a circle, and I got like a huge, let's just say it's 1 kilogram, you know what I mean? 1 kilogram out there, and my string is 1 meter, you know what I mean? So my mass moment of inertia of this setup is, hey, I've got 1 kilogram, and its distance is 1 meter, and I'm going to square that, you know what I mean? Whatever the distance is, I'm going to square it. So if I have, you know what I mean? And so how would I get inertia of 20 kilograms per meter squared if I only had this 2-pound weight, this 1 kilogram? Well, let's just do that actually mathematically. And I'm going to say the I is 20 kilograms. Oh, and then let's just do this. First thing I always like to do is the units is the equation. So we have kilograms, and then we got meters squared. So perfect. Hell yeah. So so we got 20 is equal, and then what do we want to know? We want to find the distance away to make this 20. So we can just rearrange this units equation and say, hey, we want meters squared. So we're going to take I divided by the kilograms. And we're going to have 20 divided by the 1 kilogram. And you're going to have, well, that's going to be 20 meters. Now this is 20 meters squared. You know what I mean? The whole thing is 20 meters squared. So 1 meter. So how many in 1 meter? You would have to take the square root of this to get square root of 20 to get 4.47 meters. You know what I mean? So what we solved for was the meter squared. So yeah, 20 meters squared. So we're saying that distance squared is actually like a property. You know what I mean? Whatever the distance is, we're going to square that, and we're going to call that, you know what I mean? I mean, you could think of it like this. I don't know if it's a square. But anyway, you're actually going to use that as a property. And that's the thing with weight. The farther you get away and you're still winging the thing around in a circle, I mean, it gets a little crazy. Where, yeah, the mass moment of inertia, it definitely goes up. You're going to have, it's going to take more energy to wing this thing around in a circle if it's far away. If it's real close, it's going to be real easy to wing around in a circle. All right, so I think we got that. And now we just want to convert the units from kilograms. But let's see. I found out, I just went on the internet, and it said the U.S. customary units is going to be, for I, in U.S. customary, is going to be pounds, feet, and then seconds squared. You know what I mean? And that looks different than the SI of kilograms, meters squared. So we're going to find out why, and I guess right now. It's because F equals ma. It says that if you have something defined as pounds, you can I guess we're doing this. This is slug, and then feet per second squared. You know what I mean? So you could do it that way, and this is also Newton, kilogram, and then meters per second squared. So if you can convert pounds, you can just anywhere where you see this something that says pounds, like if someone says, "Hey, I'm 120 pounds," well, you know what I mean. On Earth, I mean we've done that where you can find their slugs, but unit wise, you can just take this pounds and then so let's do that right now. So we have I as in pounds, feet, and seconds squared. So we're gonna replace pounds with this slug, feet per second squared, and then so that was pounds. So we just did this, and now we still have to have that feet and then seconds squared. So seconds squareds cancel, feet gets doubled, so now we have slug feet squared. And then that's going to look very similar to kilograms meters squared. We have a mass times a distance squared. Slug is the U.S. customary unit for mass times the distance squared. So let's do the opposite. If we said that, so this says that kilogram is also equal to, bring this downstairs, Newton divided by meters per second squared. So now we can take this 20 kilograms meters squared, and now we're gonna insert this into kilograms. So that becomes 20 newtons meters per second squared times meters squared. Okay, we only have 1 meter down here. We got 2 up there, so this meter cancels, that squared cancels. We were still left with 1 meter. We're left with newtons, and then because this is all downstairs, but this is downstairs one more time, so this does pop up. Because this is in the denominator, but it's being divided, it does pop to the top, so then we're left with 20 newtons meters and then second squared. And isn't that what we had over for I in U.S. customary units was pounds, feet, second squared. So newtons, meter, second squared. All right, hell yeah. So let's get a freshie. Get a fresh sheet of paper, and let's do this problem. Alright, hell yeah. And I just got to figure out what the hell we're even doing. But yeah, pounds, feet, second squared. So this is one way to do it. So, yeah. Anyway. Alright, so we have I in units is kilograms. They just want it converted. Okay, so we're going to go I is 20 kilograms meters squared. So now we're going to convert kilograms to slugs. So how the hell do we do that? Well, I don't know. F equals MA. We're going to say that 9.81 newtons is 1 kilogram at 9.81 meters per second squared. So we're going to say 1 kilogram is 9.81 newtons. We're going to say that 1 kilogram is also 2.2046 pounds. And I looked it up, and it's 2.204622. Oh, shoot, I didn't look it up good enough, because I think there's like a 6 and then a 22. I think this is like 100% accurate. If you do that, it's no more accurate than that, because we just invented it. We invented how many pounds are in a kilogram. Anyway, just to get close enough. Okay, so we're going to go 1 kilogram, and we're going to go 2.2046 pounds. And now we're going to convert pounds. We do the same thing, F equals MA, and we're using pounds. We're going to say that 32.2 feet per second, 1 slug, is equal to 32.2 pounds. So this gets us 1 slug is equal to 32.2 pounds. Alright, so there's that conversion. So we got 32.2 pounds is 1 slug. Booyah. Now, once we get it, and then we got to convert meters. So now we have meters squared. And like I said, the way I like to do it is just put meters downstairs once, 1 meter, and then start converting to feet. Holy Toledo, we gotta get more room on this one. So we're gonna go I. Okay, so now we're gonna 1 meter. And we're just going to say that's 1,000 millimeters. And then we're going to go 25.4 millimeters is 1 inch. And then we're going to go 12 inches is 1 foot. Booyah. Now we're at U.S. customary using that feet. Okay. But with here, we have meters squared. You know what I mean? So all these things square. The ones don't change, but this is 1,000 squared, so this is a million. You know what I mean? This is 25.4 squared, so it's like 650 something. This is 12 squared, it's 144. So definitely don't mess up on that aspect. Millimeters cancel. And then what we're going to left with is feet squared. So meters cancel, pounds cancel, kilograms cancel. We're left with slug, feet squared. Is that it? And then pounds, slug, holy Toledo. No, we're just left with mass and distance squared. We're left with slug, feet squared. Perfect. So let's do it into our calculator. So we got 20 times 2.2046 divided by 32.2 times 10 to the 6, which is a million, divided by 1 divided by 25.4 squared, divided by 144, if you want to just do it that way. Okay, so we have I is equal to, now I could just be totally wrong on this, but it says 6 million. So we got 6,34919 slugs feet squared. All right, so now let's see if this makes sense. Holy, how do we double check this just to make sure we didn't make an error? All right, so we got 20 kilograms. How many pounds is that? It's going to be about 40 pounds. So now we have 40 pounds times meters squared. Okay, cool. So let's say we just have 1 meter squared. How many feet squared is that? Well, we've already done that, and it's about 10.6. Yeah, where the hell did I get off on this one? Oh, okay, but no, we're on a roll now. So now this is going to be oh, it's because we need anyway. No, we're still good. So then we would have 400 pounds feet squared. You know what I mean? And then we want to know how many slugs per feet squared, and then so we divide by 32, almost divide by 40. So yeah, we need an answer like that's 10. 10 slugs per feet squared. So let's see where we got off. So we have, so if I did this, I think I got off like right here. So the meters squared, 100 millimeters. Yeah, that's 10 to the 6. Okay, I'm just gonna say this is 10, this is 1, this is 10, this is 10 to the 6, this is 1,000, and then this is 100. Okay, so we have 10 to the 1. So on top we got 10 to the 1, 10 to the 6. On bottom we've got 10 to the 1, 10 to the 3, 10 to the 2. Okay, perfect. So we should have 10 to the 6, 10 to the 6. We should just have 10. So yeah, perfect. So my only error was on my calculator. That's good. So we double checked it twice. This is order of magnitude. Turn everything into a 10, 100, or 1,000. You know what I mean? And if it's downstairs, do it 1 over 10, 1 over 100, or just 1 over 1,000, even 1 over 1,000,000. But then if you go 10 to the 6, it makes more sense. And then do it as do it like this. This 10 is 10 to the 1. 1 is 10 to the 0. It don't do nothing. You know what I mean? Okay, so let's just plug it in again. 20 times 2.2046 divided by 32.2 times 10 to the 6 divided by 25.4 squared. I think that's where maybe divided by, and then I put a 1 over 20. So anyway, So that gets us back in, and then 1 divided by 144. Perfect. So now we got 14.7. Holy Toledo. I thought this was going to be an easy one. And but that's good. This was a good video on like, hey, how to check for your errors. And then we're going to get an answer in mass, feet squared. And how many significant figures? We got 2. So we're going to go 15 slugs, feet squared. Okay. And in this example, yes, you could have 1 kilogram on a string that's like close to 5 meters. You know what I mean? That's close to 15 feet. That's going to give you, 5 squared. Yeah, it's like 4.6 squared. 4.5. Yeah. So you have 4.5 meters. So there you go. 4.5 times 40 divided by 12, so it's like 15 feet. So now, this is 15 feet. You'd square 15. That'd give you 225 feet squared. And you have the same, and then you have 2.2 pounds. Well, no, you have one kilogram is 2.2 pounds, but 1 slug is 32.2 pounds. So you got to divide this by 32.2. So you go 2.2 divided by 32.2. So this gives you 0.068 slugs, and then you multiply by 225. So there you go, and then you get 15. You get 15 slugs per feet squared. You know what I mean? So there you go. We just did it again, just real fast, by throwing, hey, let's just say we have 1 kilogram at whatever distance makes this 20 kilograms per meter squared, which is 4.5. Because you square this distance, you get 20. And then we only have 1 kilogram. Okay, and then I just converted the kilograms into a slug, which was a fraction. It was less than a tenth. It was less than a tenth of a slug. And then our distance squared, though, was 225 feet squared, because we already had 15 feet away, and you have to square that number. All right, so hell yeah, we did it. And again, this is slugs per feet squared. If we use our F equals MA, we can see that slugs feet per second squared, and then pounds over here. We can rearrange for slugs and say that a slug is equal to a pound divided by feet per second squared. And then we're going to put this into right there. And then we'd get 15, put in this, pounds, feet per second squared, times feet squared. This foot cancels. We're left with 1 foot on top, left with pounds on top, and then seconds goes to the top. So then we'd get 15 pounds, feet, times second squared. So that's the other way to write. And in U.S. customary units, that's what I looked up. This is typically how this is written. So maybe the final answer. But it doesn't change this number at all. So we still have 15. And I'm still getting used to writing it like that. Whoa. Yeah, so final answer would be 15 pounds, feet, second squared. So that's another way to write it. And typically in U.S. customary units, this is how they usually write mass moment of inertia. That was just from Wiki. Alright, anyway, I'm done with this one. Thanks for joining me. That was 4 problems done. We got the statics book. We'll see how many we do before we just get bored. Anyway, alright, thanks for joining me. That's a video.